Wi-Fi Protected Access WPA and Wi-Fi Protected Access 2 WPA2 are wireless security protocols that were intended to address the security shortcoming of WAP. Because the WPA protocols dynamically generate a new key for each packet, they prevent the statistical analysis that caused WAP to fail. Nevertheless, they are vulnerable to some attack techniques. WPA and WPA2 are frequently deployed with a pre-shared key PSK to secure communications between the access point and the wireless clients. The PSK should be a random passphrase of at least 13 characters in length. If not, it is possible to determine the PSK using a brute force attack by comparing the PSK to a known dictionary. This is the most common attack for the WPA security. Let's check it out. In this demo, I am using PuTTY to connect to a remote laptop that contains a wireless adapter and Kali Linux. I am using SSH to connect to this machine. The login is root and the password for that account, and I'm in. First, I need to list the available wireless interfaces installed on that machine by using the iwconfig command. The WLAN 0 is the main wireless adapter on this laptop. The next step is to create a monitor interface using the rmon-ng command. Before you start the monitor interface mode, you need to stop the network manager service first. Now we can start it. Perfect. Monitor mode is enabled. Now it's time to identify the target network. The rmon-ng command will list all the available access points in its range. When you find your target, press Ctrl+C to stop it. Let's take a quick look at our candidate. Gus Router is using channel 6 and WPA2 for security. Before we proceed, copy the BSSID of the wireless access point before you move on, because you're gonna need it later. Now open a new console window. In this new window, we will start capturing traffic between the target access point and the client using the rmon-ng command, followed by the BSSID that we just copied, then the channel. The show ACK flag is to ensure that the client computer acknowledges your request to be authenticated from the wireless access point. The -w argument is to write the output to a file. Finally, the name of the monitor interface. Leave this terminal window, don't close it, and open a second terminal window to launch a de-authentication attack. This attack will force a user to re-authenticate to the target access point and re-exchange the WPA key. We use rplay-ng for the de-authentication attack. 0 indicates that we are launching a de-authentication attack. On the other hand, 20 indicates that we will send 20 deauthentication packets. The -a is the target access point BSSID that we already copied before. And the C argument is the client's MAC address. So let's check it out. We can see that we have 3 clients connected to this wireless access point. I'm going to choose one from the list. 00C0CA413C07. A successful deauthentication attack will show here some X, which indicate that the client who was connected to the target access point has acknowledged the authentication command that was just sent. Let's switch back to the previous window and ensure that we captured the four-way handshake. Ho ho ho! WPA handshake. Here you go. A successful WPA handshake will be identified in the top right corner. Now let's stop it by using the Ctrl+C command. Next, we need to start cracking some passwords. I will use aircrack to crack the WPA key using a defined word list. Our candidate is WPA underscore log -01.cap. If you're asking yourself, Gus, how did you know the name of the file is WPA underscore log? Well, if you remember, when we started the arrow dump ng command to start capturing some traffic, we specified the -w argument with WPA underscore log. I'm not a magician, right? So I will start aircrack ng. Finally, you need to specify the path to the word list that you want to use. As usual, I will use the rocku.txt file and finally press enter. Password cracked successfully. My powerful password is password123. Now let's talk about something interesting. You can improve the effectiveness of the brute force attack using GPU-based password cracking tools like hashcat, which comes in 2 versions for GPU-based cracking. The first one is OCL hashcat for AMD and ATI graphics card. And the second one is CUDA hashcat for NVIDIA graphics cards. Let's check together my graphic card type using the lspci command. It looks like that this laptop contains an AMD VGA card. So I'm going to use OCL hashcat in my example. So what is the next step? We need to download the binaries for hashcat. I will use the wget command to download the file. Oops, I made the typo. Let's do it again. Alright, now to extract the hashcat, we need to install the 7-zip application to our host. Alright, now finally I can extract it. Let's switch to the new extracted folder. I will list its contents using the ls command. We are going to use the OCL hashcat 64.bin to crack our password. To implement our attack, first we need to convert the WPA handshake capture file to a hashcat file using the following commands. First, I will clean the captured file using the WPA clean command. Next, we need to generate the compatible hashcat file. In this command, you need to make sure that the -j argument is in capital case. To be honest, I don't like the name that aircrack picked up for me. So I will execute the same command with some slightly changes this time. Alright, it's better now. So what's next? Let's run the hashcat against the new capture file to start the cracking phase, but using the GPU power this time. I always like to run commands in a clear screen. The -M2500 is for WPA attack, followed by the name of the cap file that we just cleaned. Finally, we specify the word list file. Finally, press enter. Here we go. Password cracked successfully, but with a GPU power this time.